Okay, one last application of our trig functions is in angles of elevation and depression. So let's start by talking about what that means. So these are angles formed between a line of sight and a horizontal plane. An angle of depression is the same as the angle of elevation. Let me show you a picture to explain what I mean by that. So if I'm at this lighthouse and I'm looking down at this boat, I don't know if you can see this very beautiful little boat down here. There's my boat. So if I'm looking from the lighthouse down to the boat, this angle here is an angle of depression, because it's an angle where I'm looking downward at the boat. Okay, so it's the angle between this horizontal line, where I would be looking straight out in front of me, versus the sight line down to the boat, where I'm looking down. So that's the angle of depression. An angle of elevation would be if I were on this boat and I were looking up at the lighthouse. So straight ahead would be this horizontal line down here at the bottom. So this angle here, where I look up at the lighthouse, this would be the angle of elevation. Okay, so think of the words like, you know, when you think of elevation, how high up on a mountain are you? That's your elevation. Depression is, you know, something that goes down. A depression in the ground is you know, when you step into something, you make a depression. So think of those imagery to help you remember. Depression is an angle that goes from a horizontal down, and elevation from a horizontal up. Notice it's always in relation to the horizontal line here. Okay, this line and this one. I am not measuring this as an angle of elevation or depression. Okay, this is not either of those. And if I look at these two lines, if I'm talking about a horizontal line, then these two horizontal lines that I have are going to be parallel. Those are parallel horizontal lines. So remember what we know about parallel lines? If I have these two parallel lines and this line of sight between the lighthouse and the boat, that would be a transversal. And so this angle of elevation and this angle of depression are alternate interior angles, which means they are congruent. And that is why an angle of depression in a situation is equal to the angle of elevation. So this red angle up here and this blue one down here are going to have the same measure. So if I know one, I also know the other. So let's go ahead and look at an example using exactly this picture here, the lighthouse and the boat. So from the top of a lighthouse that is 25 meters high, a sailboat is sighted having an angle of depression of 2 degrees. How far from the lighthouse is the boat? So start at the beginning of your word problem and plug in what you know. From the top of a lighthouse, 25 meters high. So from here down to, we're going to call sea level, down to sea level, this is 25 meters. So all the way up 25 meters. Okay, for the sake of our picture here, that's what we have to use. A sailboat is sighted having an angle of depression of 2 degrees. So angle of depression means, so from where I'm at in the lighthouse, here's my horizontal, here's what I see, this angle is 2 degrees. Notice again, I didn't mark that angle inside here. I had to actually draw another line to write that angle. So that's my angle of depression. And I want to know how far from the lighthouse is the boat. So this is my unknown. This is my x value, this length right here on the bottom. So let me redraw this triangle so that I can use it a little better. Notice I have this triangle here. I'm going to redraw said triangle and label it again. 25, x. Here's my right angle, the measure from the lighthouse to the ground. Well, that's going to be right angle. I don't have this 2 degrees. Right now it's outside my triangle. But remember what we just talked about. This angle of depression is the same as this angle of elevation. So if this is 2 degrees up here, then it's also 2 degrees down here at the bottom. So I can measure this 2 degrees. So then I can look at this picture of this small triangle I have here, and I decide, well, how do I find that missing side? if I know one of the angles. And that's what we did in my last video using our trig functions. And that's what we're going to do. 2 degrees is my angle. I have the opposite side and the adjacent side. So I'm going to use tangent of 2 equals opposite over adjacent. So tangent 2 equals 25 over x. Well, how do I get x by itself? So this can be a little bit difficult if you aren't used to these kinds of questions. When I have that x in the denominator, I need to get it out of the denominator. So I'm going to go ahead and do this in 2 steps, and once you get used to it, you can just rewrite it in 1. If I multiply by x on both sides, that gets this x out of my denominator. So I have x times the tangent of 2 equals 25. I still need x by itself, which I don't have. So to get this x by itself, I'm going to divide by the tangent of 2. So that's going to give me x equals 25 divided by tangent 2. So now I have something that I can plug into my calculator. So now I can use my calculator and I can plug all of this in all at once. So plug all that into our calculator and you're going to get 715.9 meters. You could round that to 716 or you could leave it 715.9. And so that's the answer that I'm looking for here. Okay? Let's look at our next example. Next example is this one. When the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How high is the building? So I've kind of drawn a few things on this picture already. Let's go back through and label. When the sun's angle of elevation is 38. So we're talking about elevation from the ground to the angle where the sun is in the sky. This is 38 degrees. A building casts a shadow of 45 meters. So from here, the tallest point in the building, to here, that shadow, 45 meters long. How high is the building? I had trouble drawing it on the picture here, but this is what I want to know. How tall is that building? That's this measurement here, x. Okay? So again, I find that when I have all this picture stuff, it's easier just to redraw my picture. I'm going to redraw this triangle, get rid of everything I don't need. I have 38 degrees here, a 45 meter shadow, and some unknown height with a right angle. So again, just like we just did, I'm going to use that angle. The sides I have are the opposite and the adjacent. So I'm going to use tangent of 38 equals opposite over adjacent. And this one's a little bit easier to solve. I just need to multiply both sides by 45. So I have 45 tangent 38 equals x. So 45 times the tangent of 38. Put that in your calculator and you'll get x equals, it's approximately 35.1, or you could just say 35 meters is approximately equal to my height. So this building is approximately 35 meters tall. And so those are 2 examples of depression and elevation. And that's all we're going to do is just the 2 examples. So now you can use your trig functions. You can use those solving triangles in these word problems when we have depression and elevation.